Hello everyone, warm welcome to you all. Today I am going to explain about acids, bases and salts. Before getting into the topic, let me introduce myself. I am Priyanka and I completed my masters in organic chemistry. I am very passionate about teaching because I generally observed many students faced a lot of difficulty and fear of chemistry because of those gene structures, molecules and formulas, etc. But because of the passion I have on my profession, I want to make the students more clear about the subject and make the concepts more easier for them to understand. Let's get back to our topic. So, acid, base and a salt. How to identify whether a substance is acid, base or a salt? For the identification, the compounds which are having a replaceable hydrogen ions are considered as an acid. Means every compound which consists of hydrogen is not an acid. Let me clear that. By taking an example of H2O, even though hydrogen H2O consists of two hydrogens, it is not an acid compound because these two hydrogens are not replaceable. And another example for it is NaOH, which consists of one hydrogen. It is also not an acid because it is also not replaceable. Next one, coming to bases, the metal oxides and metal hydroxides comes under the category of a base, and the compounds which are having a cations which are other than H plus and the anions which are other than OH minus are known as salts. Next, what is the neutralization? When an acid is neutralized with a base and a base is neutralized with an acid and both of these are combined to form a salt. That means whenever an acid is neutralized with a base or a base is neutralized with the acid, it forms a salt. Generally, these acids are sour in taste and the bases are bitter in taste and the salt is salty in taste. Coming to the solubility of these compounds in water, all the acids are soluble in water and all the bases are not soluble, only alkali are soluble, and salts, some are soluble and some are not soluble. Example, if we consider a lemon, which is a general acid containing compound, we know it consists of a citric acid. When we squeeze it in water, it is completely dissolved. And for example of a base, we consider a soap which is dissolved completely in water. And the soap is made up of NaOH, which is a alkali. And some are soluble and some are not soluble, means a table salt which comes under the category of a salt, that is NaCl, is completely soluble in water, but the chalk which is a calcium carbonate is insoluble in water. It remains as a precipitate in the glass. And next, indicators. There are two types of indicators for the identification, natural indicator and synthetic indicator. These natural indicators, we have taken an example as a litmus paper. In this, when an acid is cupped on or a blue litmus paper is cupped on an acid, it turns into red. And when a red litmus paper is kept on a base, it turns into blue. And coming to an acid, either it may be a red litmus paper or a blue litmus paper, there is no change in the color. That means it remains unaffected. Coming to the synthetic indicators are those which are prepared chemically in a lab. I am giving you two examples here for synthetic indicators. One is phenolphthalein indicator, which is colorless, and methyl orange indicator, which is orange in color. Phenolphthalein indicator, when added to an acid, it remains colorless, but when added to a base, it changes to pink. And on a salt, it has no effect. Coming to methyl orange indicator, which is generally in orange color, it converts into a red color when it is added to an acid. It converts into a yellow color when added to a base, and on salt, it has no effect. And we have another way for determining a compound or knowing the pH value of a compound by this method. If the pH value lies between 0 to 7, then the compound is said to be acidic. And if the value lies between 7 to 14, then the compound is considered as a base. If the value is 7, then it is considered as a neutral compound. The general example for a neutral compound is water. If we check the pH value of a water, it remains as a 7. Next, here when the pH value decreases, the acidity basically increases. That means pH value is inversely proportional to acidity, and as the pH value increases, basicity increases. So pH value is directly proportional to basicity. This is about the chemical explanation of acid, base and salt. Coming to our general life, we have used many acids and bases and salts in our daily lives. For example, our human body consists of a bile juice, which is generally an acid used for digestion. If the levels of the acid or the bases present in our body has increased or decreased, it may be causes a severe effect on our healthier life. Hence, we have to maintain all those in a balanced way to live a very healthier life. So that's all for the topic. Thanks for watching.